This lesson's on section 4.4. We're going to prove that lines are parallel. Before we do that, we're going to do a little review about a conditional and its converse. If you study, then you will do well. Notice how we highlighted the hypothesis in blue and the conclusion in red. If you want the converse, you're just switching the red and the blue. So the converse would look like this. If you do well, then we use all the same words here, but these have a different meaning. If you study, then you do well does not mean the same thing as if you do well, then you studied. It's possible you could do well without studying. And it's also possible that you could study and not do well too. But these don't have the same meaning. The last two sections, we learned these three theorems in this one postulate. Here's your hypothesis. When you have parallel lines, alternate to your angle are congruent. That's your conclusion. Or you could say alternate exterior angles are congruent, or corresponding angles are congruent, or your consecutive interior angles are supplementary. Those are all your true conclusions. Now, if we would take the converse of those statements, if any one of these things happen as your hypothesis, then that would make parallel lines. So we'll start with parallel lines. We start with angle pairs that have a certain relationship. That creates parallel lines. So we're going to have four ways to show that lines are parallel. And that it's very familiar to you because these are the converses of the things we've studied the last few days. So if you have congruent alternate interior angles, that means the lines are parallel. If you have congruent alternate exterior angles, that means the lines are parallel. If you have congruent corresponding angles, then the lines are parallel. If you have consecutive interior angles that are supplementary, then the lines are parallel. The problems in this section are going to look very similar as well. Only difference being, notice how the lines are not marked parallel. What you want to do is find a value of x that would make them parallel. You basically do the same exact thing. You need to identify the angle relationship. These are alternate interior angles. What relationship do alternate interior angles have to make the lines parallel? Well, you need them to be the same. So even though you don't know what this is and you don't know what this is, you know they need to be the same if the lines are going to be parallel. So you're going to write this equation. 5x plus 2 equals 4x plus 22. Then you're going to solve for x. A good first step would be to subtract 4x from both sides. Okay, guess my mouse is not going to work right now. So we'll subtract 4x from both sides. That's going to give us a much more manageable equation. That'll give you x plus 2 on the left side, and that's going to equal 22 on the right side. So what number plus 2 gives you 22? That's what that says. You should probably know. 20 plus 2 gives you 22. So that's our value of x. X equals 20. If x equals 20, then these two lines are guaranteed to be parallel. If x is not 20, then these lines are not going to be parallel.